Hello everyone. So here in this problem we have to find out value of x, y and z using Cramer's rule. If we have been given three equations and these three equations are with three variables. So by using these three equations we have to find the value of x, y, z and we have to make use of Cramer's rule. So to apply the Cramer's rule we want these equations in standard form. So first of all we'll bring all the equations in the standard form. So here this equation is already in the standard form, so I'll copy it down as it is. So x plus 2y plus 3z equal to 6. I'll say this as equation number 1. For the second equation I'll take this z on the left hand side, so it will become positive z. So 2x plus 4y plus z is equal to 7. Next, in the third equation I will take this minus 2y on the left hand side, so it will become positive 2y. So this will become 3x plus 2y plus 9z is equal to 14. So I will make this as equation number 3. So now we got three equations with variables x, y and z. So now we will apply the Cramer's rule. So to use the Cramer's rule we want the value of d, dx, dy and dz, and to get the value of d, dx, dy, dz we are gonna use the Saru's rule. So by Saru's rule we can get the value of these four quantities. So here I will say by Saru's rule the d is equal to, now d is nothing but the determinant of coefficients of variables. So here the first variable is x and the coefficient of x is 1, here it is 2 and 3. So 1, 2, 3. The coefficient of y are 2, 4, 2 and the z are 3, 1 and 9. So we will find out the determinant of this matrix to get the value of d. So here it will be 1 into determinant of 4, 2, 1, 9, then minus 2 and 2, 3, 1, 9 plus 3, 2, 4, 3, 2. Now here we will get 1, 9 4s are 36 minus 2, minus 2, this will become 18 minus 3 plus 3 and this will become 4 minus 12. So we will get 34, here minus 2, 15 plus 3 into minus 8. So we will get 34 minus 30 minus 24. Now 34 minus 30 is 4 and 4 minus 24 is minus 20. So the value of d is minus 20. Now let's find out the value of dx. So to get the value of dx we replace the coefficient of x by the constant. So here the coefficient of x are 1, 2, 3. So here I will replace this coefficient by the constant. So it will become 6, 7 and 14 in the first column and remaining two columns will remain as it is. So therefore dx is equal to determinant of, now we will replace it by the constant, first column 6, 7, 14 and the second and third column is as it is. So it was 2, 4, 2 and 3, 1, 9. Now let's find out the determinant of this 3 by 3 matrix. So we'll copy down the first element, that is 6. We'll hide the first row and first column. So we'll get these 4 elements. So we'll write it down, 4, 2, 1, 9. Next we'll take the second element and we'll give the minus sign. So minus 2. So this 2 is in the first row second column, so I'll hide the first row and second column. We'll get the 4 elements 7, 14, 1, 9. So it is 7, 14, 1 and 9. Similarly, we will take the third element, that is plus 3. 3 is in the first row, third column, we will hide it. We will get the elements as 7, 14, 4 and 2. So by solving this, here we will get 36 minus 2, 7 9s are 63 minus 14 plus 3, 7 2s are 14 minus 56. So here we will get 6 into 34 minus 2. Now 63 minus 14, that is 49, plus 3 into, now 14 minus 56, and this will be minus 42. So now by multiplying this 6 with 34, we will get 24, 18 and 2, that is 20. So 204. Here we will get 98, and here we will get minus of 126. So by doing the subtraction, here we will get 204 minus 98. So it will be 106 minus 126. So it will give us minus of 20 again. So we got the value of dx as minus 20. Now let's find out the value of dy. So therefore, to get the value of dy, we will replace the coefficients of y with the constant. So the middle column will change and the first and third column will remain as it is. So first and third column is, the first column is 1 2 3 and the third column is 3 1 9. So we will change the middle column. So the constant are 6 7 and 14. I will replace it over here. So it will become 6 7 and 14. Now let's find out the determinant. So here we will get So let's solve this. So here we will get 1 as it is, 7 9s are 63 minus 14 minus 6 into 18 minus 3 plus 3 into 28 minus 21. So here we will get 63 minus 14, that is 49, and 49 into 1, that is 49. 18 minus 3 15, 15 6 are 90, so minus 90, and 28 minus 21, that is 7, and 7 3s are 21, so plus 21. So if we will solve this, then we will get 49 plus 21, that is 70, and 70 minus 90, that is minus 20. So again we got the value of my dy as minus 20. Let's find out the value of dz. So therefore dz equal to, now to get the value of dz by Saru's rule, what we do is we replace the coefficients of z by the constants. So here the coefficient of z are 3 1 9, we replace it by 6 7 and 14. First and second column will remain as it is. So 1 2 3 2 4 2 as it is. So 1 2 3 as it is, 2 4 2 as it is. The last column will be 6 7 and 14. So here 6 7 and 14. Now let's solve this. So here we will get So by solving this, here we will get 1, 14 4s are, that is 56, minus 14, minus 2, 14 2s are 28, minus 21, plus 6 into 4 minus 12. So here we will get 42, 42 into 1, that is 42, 28 minus 21 7, 7 2s are 14, so minus 14. 4 minus 12 minus 8 into 6, that is minus 48. So we will get this 42 minus 14, that is nothing but minus 28, and this 28 minus 48 will become minus of 20. It means the value of dz is also minus 20. So we got the value of d, dy, dx and dz all as minus 20. Now let's apply the Cramer's rule to find out the value of x, y and z. So therefore, by Cramer's rule, we'll get x by the formula dx upon d, which is nothing but minus 20 upon minus 20, and it is equal to 1. Similarly, we'll get y by the formula dy upon d, which is minus 20 upon minus 20, which is again 1, and the value of z is dz upon d, which is minus 20 upon minus 20, and will again get 1. So the value of x, y and z is 1. Thank you.